This video will be discussing the binary numbering system. I know that that just sounds fun and awesome. So many of you may have already been introduced to the binary numbering system if you took some computer science courses in high school, or maybe you've already had some at the college level. But the binary numbering system is something that is important to be familiar with if you are a computing major. And if you are not a computing major, it's still just pretty interesting to know that you know a new numbering system. So let's start out with something familiar. I will say I'm going to stay in edit mode for this PowerPoint because I'm going to be editing some of the slides as I talk through some things. So maybe a little bit of a non-traditional presentation format. Anyway, let's start with something that you know. You know the decimal numbering system because that's what you have learned since you were very small. It is the most commonly used and obviously the most familiar one to the general public. It's also known as the base 10 numbering system because it's based on 10 symbols. And again, you are familiar with those symbols 0 through 9. And to make any number, we use a combination of all of those symbols. So what is binary? Binary is also known as base 2 numbering system. It is the simplest kind of numbering system because it only uses 2 digits, and we're going to use 0 and 1 to represent that. So by using these digits, computational problems can be solved by machines because in digital electronics, as you may have learned in 1403, a transistor is used in 2 states. So those 2 states are represented by 0, which means false, and 1, which means true. So again, in 1403, you learned that a bit is a binary digit and that bit patterns are used to represent all kinds of information, numbers, text, images, sounds, and other things. So here we're going to focus on representing numbers, just number representation. Again, let's go back and revisit the decimal system or base 10. So if you are given a number like 375, you know what that means because you've been taught that the decimal system is based on powers of 10. And so I kind of have a grid here to show you that that first place, what we call the ones place, that is 10 to the 0 power. Anything to the 0 power is 1. And the next place over, we call it the tens place, and that is 10 to the first power. So anything to the first power is just that number. And then that third place over, we call that the hundreds place, and that is 10 to the second power, or 100. So here are the powers and here are the values. And so when we are given a number 375, what that really means is, hey, I need 3 of the hundreds. So we take 3 times 100 to equal that 300. And same here. So this is kind of how the new Common Core math is working, is it's really wanting you to have an understanding of those place values. All right, let's move on to binary. So binary works exactly the same way in that you have places and each place is worth a certain value. So just like I did on the previous slide, this slide has a grid of powers of 2. So we see that 2 to the 0 power is 1, 2 to the first power is 2, and so forth. And so you see these values doubling as we go through. And if we go out to 8 places, and remember that 8 bits make a byte, we see that we can make 256 unique values or unique combinations of zeros and ones in order to represent, in this case, numbers, because that's what we're talking about. But you know, we mentioned in the 1403 class, if you've watched those videos already, that it can be used to represent a variety of things. All right, so just again, a side-by-side comparison, just to show you that you really already know how the system works. And we already looked at base 10 and the places, and now base 2 and the places. So of course we can't represent as high a numbers with only 2 digits as we can with having 10. All right, so let's get on into how we do conversion, because our brains have been trained for 18 plus years to work in base 10. And now we have to do a little bit of retraining to get them to work in, or at least understand how base 2 works. So let's look at how we might go about converting a binary, some binary digits into decimal so that our brain understands what does 11101 mean if I'm talking about representing numbers. And so all you really have to do is plug that number into this table. So I would suggest, you're going to be doing a lot of this, I would suggest that you take out a piece of paper and that you draw this little grid on there, because that's going to be really helpful to you. Again, if you're new at this and you've never done it before, this was super helpful to me when I first started learning. So I've got 5 digits here, all right? And I'm going to start over here on the right-hand side. So I'm transferring this 1 into this first place. Whoops, I didn't mean to do that. And so 1, and then moving over, that's a 0, and that's a 1, 1, and 1. Okay, so I have now plugged this, these binary digits into this table. Now, how do I know what that means in decimal form? Well, the second step here says add up the values in that second row that have a 1. So this spot has a 1, and that place is worth 16. So I'm going to say 16 plus, and the 8, or the this position has a 1, so I'm going to add the 8. And as I just keep going through, I'm going to add the 4. Now, this has a 0, so I don't add the 2. But down here in this place, I'm going to add a 1. And then all I have to do is go through and add those up. So 16 plus 8 is 24, plus 4 is 28, plus 1 is 29. So in the binary numbering system, 11101 is equal to the decimal value 29. Well, I can't seem to highlight it, but so 11101 is equal to 29. So that's how I take an existing binary number and convert it to decimal. Let's look at going the other way. If I'm given a decimal number, how do I go about converting that to binary? Well, it's really sort of the same thing. So given that we could get a lot bigger, we could go 2 to the 9th and all of that. I'm keeping us within these 8 places just for simplicity's sake. But so I want to convert 78 to binary. So I find, where in this table does 78 fit? Well, it's between those 2 values right there. Okay, so 128, if 128 had a 1 here and all the rest were zeros, then the value would be 128, and that's too big. So I'm not going to need these 2, okay? And you can put zeros in there if you want to, but you don't have to do that. I do need the 64, okay? So that gets a 1, and I've kind of worked out these steps here. We plug a 1 in below the 64, the 2 to the 6. All right, now, does this one get a 1? Here's how I figure that out. What's 64 plus 32? And I've already done the math here. That's 96. Well, that's larger than 78. And so if I were to put a 1 here, then that value already is 96. That's too big. And I'm trying to create 78. So that gets a 0. And I just keep going through and asking those questions. Well, I already have 64. So 64 plus 16 is 80. That's bigger than 78. So that gets a 0 also. All right. Then my next one is, what's 64 plus 8? That is 72. So I need that one to get me up to 72. Okay. Do I need the 4? Well, let's see. How many do I have already? 64 plus 8 is 72, plus 4 more is 76. Yes, I need that one. And so I'm up to 76. Do I need this one? Yes, because that gets me to 78. And since I've now equaled 78, that means that that place gets a 0. So I just solved. And again, you can leave off preceding zeros, but 78 in binary, just to get it up there for you, would be 1, 0, 0, 1, 1, 1, 0. And we did that just by plugging things in the table here. Okay, now you get to practice. Again, I would advise you to create that, a table similar to this. And then I would pause this video and you try to work these out both ways, converting these decimal values to binary and converting these binary numbers to decimal. And the answers are on the next slide, but I would pause the video and attempt to do that. And then I'm going to go ahead and put up the next slide so that you can check your answers. Okay, so this one, this is how you would determine the binary values for those decimal values that you were given. Again, you can pause this video if you want to take a look at this a little bit more closely. And then here are the solutions for the other way. Given the binary, how do you solve for the decimal values? So if this is brand new to you, this may be a video that you want to rewatch, or you can certainly Google the binary numbering system. There are some other videos out there. I looked at several, but most of them covered more than what I wanted to cover with you, and so I decided to just go ahead and make my own. There will be 2 other videos following this one, because once you learn how to do this conversion, we're also going to talk about how to add in binary, which is really quite simple, but I've got a video on that. And then you also need to be familiar with hexadecimal, and so those videos should follow this one.